Okay, so hi, I'm Greg Ferro, and I'm the host on the Packet Pushers and also blogging at etherealmind.com.
Russ White, VeriSign, Principal Research Engineer, Routing Geek Network Architect, and blogging at Packet Pushers.
Tom Hollingsworth, the networking nerd. I blog at networkingnerd.net.
I'm Derick Winkworth, otherwise known as CloudToad. I'm at CloudToad. I also blog on Packet Pushers.
I'm Stephen Foskett from blog.foskets.net, and I'm on Twitter at sfoskett.
Omar Sultan, Senior Manager Emerging Technologies from Cisco.
Ethan Banks, host on the Packet Pushers podcast and blogger at packetpushers.net.
And we're here today to talk with Omar about Cisco's recent announcements on their SDN strategy. And this is part of an ongoing series of virtual symposiums in partnership with Tech Field Day. And although most of the engineers around the table are packet networking nerds and tend to be drawn from the Packet Pushers, this is part of the Tech Field Day team. And we've been getting together with Cisco and with other companies to put on these virtual symposiums to go deeper into the technologies that in recent announcements. So instead of just sort of reading a bit of a brief and a 500-word press release, what we want to do is talk about the impact here of what Cisco's SDN strategy means and how we want to interpret it in terms of how it fits into the marketplace. So it's not just about, this is what the API does and this is a controller and this is the stuff that's being released. What is the impact of that have on our network? So I've talked a lot, and Ethan and I, we've wailed on about OpenFlow for the better part of a year now and made various hypotheses and guesses and gesticulations about how fantastic it's going to be. Now we're actually seeing that come to fruit. So what does that look like now that Cisco's putting that out, and what's going to be the impact? So Omar Sultan is here. He's representing the product, the technology, and he's been giving us a bit of a brief. So rather than rehash that and go through the presentation, that will be available at other places, and we'll get some links into the show notes to the Cisco press release and the supporting web content so you can catch the details. But here, what we're looking to do is do a bit of a roundtable discussion about what the shape of SDN will look like over the next year now that Cisco is going public on their announcements for the strategies. Is that a reasonable summary?
Sounds fair.
Sounds fair. So I guess the first part to talk about is that the strategy that Cisco is bringing to the table kind of breaks down into three key functionalities. One is the 1PK strategy, which is the announcement around the APIs that will be available in the three primary operating systems that Cisco has. So you will see can't say ONE, can I? It's one. Is it one? Or we can't say that?
One network environment.
One network environment, which is the open network environment, is the correct name of the system. And Cisco is declaring OpenFlow support available for iOS, iOS XR, and the Nexus platforms. So that fundamentally means just about everything in the Cisco range will have some early code releases suitable for development environments where you can start working with OpenFlow and controllers, right? And this, including 6500s and iOS 37 at time, some of it will take a while to filter down and so forth. So that's the one leg of the announcement. The second leg of the announcement is that the OpenFlow 1.0 controller agents will be available in those code streams.
Yep.
And then the final part is that the Nexus 1000 V platform has a whole raft of new features associated with it, which enable a whole an extension of the OpenFlow or the SDN environment right the way up to the virtual machine in the end host.
Yep.
And so we're going to sort of move around a little bit. I doubt we're going to have a whole lot of structure. We're going to sort of throw some topics out, bounce them around, and hand the discussion around to the people around the table because we've all got opinion.
Some of us do, yes. Apparently.
Okay.
So I'll lead in with a question here, which is Cisco's making an SDN announcement that is different from what a lot of the other popular SDN guys are doing. I think when folks think of SDN, one of the things that comes up in their mind is a controller, a centralized controller that's pushing down flow and forwarding information into switches from that controller, and the controller is centralized and so on. And the Cisco announcement isn't that. This isn't a controller play. This is a whole series of APIs. Why did you guys go that direction and not go with a centralized controller model?
So it's really an all of the above play, right? So we have the APIs, we have controllers and agents that we're playing with, and then we have the overlay piece. I think the thing for us, and maybe the central piece of the announcement, is there is no one size fits all for SDN. We've been quiet for the last year and a half. We spend most of the time talking to customers, and the thing that really came out is while there's a common term in SDN, if you ask them what they really are trying to do, it's very different. It really varies across different segments and different markets. So what universities are trying to do are different from what service providers are trying to do. And the enterprise folks, for the most part, are still trying to figure it out. So we really didn't believe there's a one-size-fits-all, or we should try and herd everyone into towards a particular perspective. So you kind of see some flexibility in terms of approaches.
Do you see that being an advantage for Cisco? Because, I mean, from the SDN talk that I hear, it's almost like there's Hatfields and McCoys, there's battle lines being drawn. Mm-hmm. Either you only support APIs or you only support OpenFlow. And they don't want to admit that the other side really exists. And you guys are kind of playing peacemaker in the middle, saying that's what we can do, though. Do you see that as a big advantage?
I think it is. I mean, I think there are very different use cases across them, and there's a lot of, the technology's still up in the air. I mean, we've been doing on the SDN for a year and a half, maybe. A lot of the code's 1.0. I don't think we've hit the zenith of SDN technology development with what's on the table right now. So I think this stuff will continue to unfold on the API side, on the technology side, and I think the biggest thing is the use cases really are not gelled. I think customers have an idea, programmability applies to, intrinsically says, oh, this is cool, I'd love to have more control, I'd love to have more flexibility. I think those kinds of things absolutely make sense. When you start digging below that and ask, okay, so what do you want to really accomplish? I think that's still wide open. There's not a lot of, okay, this is exactly what I want to do. And then a lot of the technology flows into place. Right? When you have the conversation offline about, how do you design stuff? You don't start with, okay, I'm going to use MPLS and drive everything through that. You're trying to understand what you're trying to accomplish, and then try and figure out what the best, you need a hammer, a screwdriver, or a wrench.
Yeah. So it seems like Cisco is really trying to do a flexible platform to use as you watch things evolve in SDN over the next few years, instead of trying to say, this is our game, and if you want to play our game, you can play our game.
Yeah, I mean, I'd love to say we're being corporate and altruists, which is, we're trying to be flexible because that's something we're trying to do. But I think at the end of the day, the customer use cases are not clear. So you would say, this is what you should do and drive. And there are places where we'd say this is the technology we should use because it makes sense. Here, you talk to 5 customers, you get 6 different opinions about what they're trying to accomplish. I mean, even with we have service providers, are an interesting example, right? For them, if you look at the hyperscale folks, the Yahoos, the Facebooks of the world, for them, they want like really deep insight into what their switches are doing, like ASIC level counters and those kinds of things, because they're trying to build their own control planes. Other types of service providers say, I'd really be able to love to run my own version of BGP that's tuned to support the way I've built my network. If you ask them, they'll both say that's SDN. They're wildly different things. You talk to university, we got like Matt Davey talking on the panel for us. He's talking about network slicing and being able to provision IDS on the fly and those kinds of things. So until, I think SDN may end up being, a peer to routing.
Yeah.
Okay, it's a capability. What that really means?
It's another view of the control plane is what it really is. Whether you call that routing or switching, it's another way of looking at the control plane that somehow has to interact with the existing control plane and make use of it. So every control plane use case you have today is going to be an SDN use case, which is MPLS-TE offline and online. It's going to be BGP. It's going to be policy-based routing. It's going to be all of that stuff is going to be the same use cases that you're going to have here as a baseline to start from.
I absolutely agree. I think it really depends on the way the market goes, right? It could be something like that where it just becomes a horizontal capability that's just part of how you do networking. Or as we've talked, right? It could just be glorified network management. It depends on how it unfolds, depends on whether developers buy into doing it. I mean, the someone still needs to actually code this stuff and support it and do those kinds of things.
Well, if it brings network management and the control plane together in some way in which way they've never been brought together before, that's not a bad result necessarily from a network complexity and a network configuration.
There's more potential than that, though, because this could be a whole new paradigm in way to do networking.
Yes, it could.
You could, theoretically, you could programmatically use SDN to set up your own forwarding paradigms and do things your own way that are not necessarily standards-based even.
Right.
Which isn't necessarily a good thing, I guess, but you could. I mean, SDN has that potential.
Well, the networking industry is always about road. right? Now, whether you build a hangman's noose from the rope or a signal tower, that's kind of your choice. But that's what we do for a living, is we give people rope, right?
But I think that the idea of doing the flexibility that Cisco wants to do is really helping people out, because you have people now that look at OpenFlow and SDN as a way to do what they've always done, just a little bit differently. And with flexibility comes the idea for someone to think outside the box and go, yeah, I don't want to do that. I want to do something really super cool, like Ethan's blog post about having a network that will provision itself with 2 or 3 clicks. I mean, that kind of functionality that doesn't exist today, but can exist when you look outside by using a completely different control.
Yeah.
Well, I think part of the vision here is I remember in the late 90s when SNMP arrived. And we were all very excited about SNMP because it was finally going to give us network visibility.
And the excitement quickly.
Very much so. Yeah.
Yeah.
And Bay, Nortel of the day, Wellfleet, with their SNMP and configuration of the whole device via the SNMP was, just something they weren't able to do. So in the sense that OpenFlow could be an SNMP, it makes sense for the vendors to be cautious if you sort of frame it in terms of that debate. And there's not just SNMP 10 to 15 years old, there's a whole bunch of things that have happened over the last 10 years with, like, forces, right?
Right.
There's been any number of distributed control plane APIs. We've had Armon, which rose and fell. We've had,
You look at the network complexity problem we have today, and a lot of it seems to stem around getting the information we need somehow transferred out of these network management stations and into the control plane to actually make the network do what we want to do. And today, what connects those things is a human mind going, oh, look, I've got a really hot port there. I need to transfer some traffic over here, which means I need to go mess with my routing. Now, if that human mind could then make that into an algorithm or into a heuristic that then works and makes the control plane work with that information and draw up and push down, that's a completely new way of working.
And I think
the world.
that's I think that's a trick. When you start linking, we talk about these feedback loops, right? Trying to be able to look at analytics and start linking that with policy implementation, then being able to link that all the way back down to the switch. I think that's where you really move the ball forward. I think if we don't get to that point, a lot of it is just a different way of skinning the cat.
Well, today, and it also comes down to configuration management. And when I say configuration management, I'm talking about change risk. So in today's networks, we have these autonomous systems, whether they're OSPF or OPLS, and all the protocols, we have each device calculates its own network view, and then it talks to the one next to it, and they all get their own view. And then, so every router has its own vision of the network hierarchy. And so a configuration change here has a knock-on effect right the way through. And so today, it's very easy to make a mistake that actually pops the entire network and then causes an outage, or far too easy. And this then causes ITIL to overstate risks, and then this causes change freezes or feature retardation as the networks lock up into stagnation because of fear of making the change in the network environment. In that sense, we in networking have always relied on autonomous protocols like OSPF to do things. And then the reason that we chose autonomous protocols, in my opinion, was because that was the only way for the system to automatically respond. Now, in the last 10 years, we've seen real stride forwards in distributed computing and also controller plane decisions. So technologies like Hadoop and MongoDB, where they have cluster type driven technologies, allow us to build distributed controllers that we haven't had today before. And that's what's in my mind when I say I see SDN in the use cases that I can sort of envisage around SDN, is that we've got new technologies that we didn't have 15 years ago when SNMP was around. It took us 15 years to make something of SNMP.
Yep.
The SolarWinds, the net managers, the HP OpenView. I mean, they all do a great job with SNMP, but the ultimate thing is that even in 2003 we agreed, the IETF released a standard saying that configuration management of SNMP just wasn't going to happen, simply because you configure something but you had no rollback capability in SNMP, or you couldn't get enough granularity.
But I get that, but I guess 2 points. First, new and different doesn't equate to better. It just means new and different, and some could argue unproven and steep learning curve. I think the other piece, it doesn't still move you away from the fundamentals of good engineering, right? As a good engineer, you learn to manage your failure domains, and you learn to constrain them.
Right.
SNMP or Armon or any of these technologies are not going to magically help you figure out what the right, what the right configuration and what the right failure domains are for a particular environment. So it's a new tool. It may not actually move you any closer to that.
In growth, it's worse because in some ways it actually ties failure domains together on the back end that then cause you then to have positive feedback loops, which are ultimately the cause of every network failure in the world.
And I'm actually concerned about what you're saying in terms of the effect on ITIL and corporate governance. I mean, if you're worried about them not wanting you to reconfigure the network, well, just imagine if the entire network is behind one brain. I mean, they might even be more scared of that. Now, the way that OpenFlow works is a little different than that, but, the boss isn't going to know that. He's going to think, okay, so you want my entire network controlled by a controller?
Yeah.
Are you crazy?
Okay, so let me paint the proven pathway that already happens today, and it's called VMware or Zen or Hyper-V. Are you saying to me that last year we had 500 servers, physical servers, and each one was alone, and it was nice and safe? We could change each one without having to worry about anything.
At least that's what we thought.
Yeah. And then we put VMware with vCenter, which is a controller-based network of servers. And look at the value that has brought to, forget virtualization and 20 to 1 oversubscription ratios and average utilization.
Yeah, the benefit of virtualization is not in utilization. The benefit is in the additional features that it brings.
The centralized controller brings configuration management of the server farm and allows you to get a new take on the data.
We're not even talking, what Cisco's announced here, we're not even talking about centralized controllers especially. We're really talking about a whole different model. You guys didn't go that way. I would say Cisco's even got almost a cynical viewpoint about OpenFlow compared to what the tactic that some other vendors have taken.
Well, so sample's probably a little bit strong, but I think there are a lot of tools out there, and there are new technologies and there are old technologies, and I think as everything else, it shouldn't be chasing the bright shiny object as much as what to do and what to do well, and what to do better than what I have already.
Yeah, Cisco could have come out with the Cisco thing, and it could have been a big shiny controller that does the Cisco thing in this one. They didn't, and I don't know if that's cynical or just pragmatic.
It is pragmatic because it doesn't force you to displace whatever you've got in your network to put in this new thing. You can layer in APIs and then begin to extend the capability of your network and change them around, which, Derick, I don't know if that's gone through your mind at all.
Oh, it has. I like Cisco's approach immensely because the real question is why do people get excited about OpenFlow and SDN? I know eventually I had to come to terms with my over-exuberance in the beginning. And it was largely because, okay, I can program the network now, right? I mean, and I was we were starting to do that in our own company with things like netconf and GenoScript and onbox tickle scripts and those kind of things. And we started to realize, wow, if we just had the right abstractions and the right access to these boxes, we could really do some amazing things that would simplify our lives, allow us to introduce new services. And it's really about network programmability. It's not about OpenFlow. OpenFlow is whatever. You can have a completely programmable network and not have OpenFlow. And that's what I like about Cisco's approach. I think that's the right way to do it. And it's neutral on any one of those tools, right? It's not like, OpenFlow is, I don't think they're negative about it. I think what it is just another tool in the box from their perspective.
And maybe that's a cynical attitude. Maybe that's what Ethan was trying to say. If OpenFlow is not a revolution and is just another tool in the box, does that marginalize OpenFlow?
I don't think it does. It's a 1.0 protocol. It's heading out the door. It'll go someplace where it won't. I'm not trying to.
Well, in fairness, the spec is further than that, but I haven't seen any implementations.
1.3. 1.3 is that one. They're working on 1.3.1. If you look at anything that anyone's touched, in terms of shipping, it's all 1.0 and incomplete 1.0. That. So,
but let's not minimize the revolutionary possibilities either, because in the long run, right? I mean, laptops 1.0 weren't very revolutionary. Now they are, and I think a lot of the revolution though has to happen in our heads and not in the protocols and not on the paper. Network engineers need to start thinking about what can I do with this? How does it change my life? How can I apply it? And get out there and start applying it in the real world. Otherwise, the revolution's never going to happen anyway.
Completely agree. I mean, I think personally, this is my job, right? So I'm very up on programmability. But I think it's about decoupling control and data planes. So decoupling the what and the how. So absolutely mind shift, right? If we look at programmability, if we can program the network, to your point, what kind of stuff can we do? I think there's an immense amount of coolness that can come out of that. The how, it needs to be a different question, right? Okay, there are multiple hows, and you can actually have programmability with the stuff that's sitting on your desk right now. You don't have to have, go chase unicorns to get programmability in your network. So absolutely, I think the cool part is getting people to shift their thinking, both on the network side and on the developer side.
Yes.
So the how is still...
The developer is a very interesting point, because we've got a massive change happening. One of the things that we've seen in other areas is the exposure of APIs to technology. So
Yep.
cloud companies have used programmability to drive efficiencies in their business.
Mhm.
So public cloud companies basically use APIs. And that's changed the thinking amongst the server and the applications and the storage people, because even storage is now largely API driven. The storage industries are saying...
It's getting there.
Yeah. But you don't just change these things overnight.
No.
And so
and also, you don't ditch the old necessarily. You come in with something new, and eventually things change.
Yes, and so I see this perhaps in my less cynical moments. I might see this as the first step down a pathway where we put some OpenFlow. Cisco's putting some OpenFlow into the market. Now let's see what floats and what sort of APIs seem to be working. What sort of scripts, what sort of initiatives come from people to say this? I can see what this does. How can we do this how thing? I can see what OpenFlow is. Now tell me, this is what I want to achieve. How can I do that? And that's what, in a sense, you're sort of throwing it out there and saying, come and tell me what you can do with this.
And from a network engineering perspective, a lot of the danger is going to be, oh my goodness, it's the end of routing, it's the end of Trill, it's the end of, spanning tree. Well, that wouldn't be a bad thing. Okay, the last one. We can do it on the spanning tree stuff. But it's the end of everything I know. It's really not. It's just, you've just got to reach out there and try it and see how it mixes with what you've got and use it.
Yeah, that is a good point. None of those other technologies are going to go away.
Probably not ever. About spanning tree.
Probably not ever.
Probably even spanning trees are around.
That's very sad.
And that's a good point. That's another thing. The second thing I like about what Cisco's approach is that I've been pretty vocal on my blog how these SDN vendors have no interest in their interoperability. They're that's my favorite thing to say. Single system image solutions that they're disembodied line cards with a soup that's a standalone box, right? I mean, you can kind of think of it that way.
Yeah.
With some magic they put on that soup, but guess what's not on there? Stuff you need for that system to interact with the rest of the world. Because the rest of the world, for all the negativity there is about IP and the way networks are built, it's funny that they're complaining about it over a network that's built over the thing they're complaining about. And you're going to have to interact with that indefinitely. OSPF, I don't see that going away. You're going to need to be able to route in between clusters or islands of SDN, right? Is it all going to be? You're going to program flows, across the world through 5 different autonomous systems? Maybe, but I don't think that's going to help.
I think so. I mean, I've heard people that argue all I need is OpenFlow and I go program stuff. Great. I mean, if you've got 5 flows, great. If you got 20,000, it's probably not going to work that way. But there are probably 2 challenges I see with the conversations these days. I think to some degree we've made networking too easy. It's a utility for the folks that consume networking, not the ones that run it, but the ones that use it. It seems stupid easy. It's like the consumerization piece. I buy a Linksys or I buy a D-Link, plug it in. I'm a network engineer because I've networked in my 2 iMacs and my Apple TV. It really doesn't work that way, but that fact is lost on a lot of decision makers, especially as decision making moves into the line of business and outside of IT. I think the other piece, personally, because I've been doing this since I had hair,
which you're losing rapidly.
A lot of it through this launch. I should have done a time lapse. But and to your point, at the end of the day, a lot of these folks are standing on the shoulders of networking. These 6,000 RFCs that people like to, yell and complain about. The reality is, you're standing on the shoulders of all that stuff that's gone before you. And I think the startups that get that will be successful. I think the ones that don't are going to have a tough time, because at the end of the day, networking is hard stuff. It's
distributed systems.
Yeah,
the thing that a lot of people don't understand is a network is thousands of devices pulling together into a coherent system.
Yeah.
That is rocket science, right? A server doesn't have that. the other parts of your storage infrastructure, an application, a typical
Routing
web
is still
application
hard.
has a web server, an app server, and a DB server.
Yeah, 3 tiers are done. Yeah,
Three tiers are kind of done. I mean, they're internally complex in their own right, but they're not pulling.
Okay, go ahead. Keep going.
Isn't it all just scuzzy after all?
It's all just scuzzy.
A great analogy, and you actually said the magic words.
Yeah.
It's rocket science. When we sent men to the moon, we had to build science and technology that we'd never seen before just to get people off the planet. But we still had to rely on old technology to help that happen. I mean, unicorns did not carry men to the Saturn V rockets. They still had to ride an internal combustion.
They pulled the chariot, duh.
Exactly. So I mean, don't forget the things that help you, get to that magical place where, the network programs itself and all these other things. You still have to rely on all the other stuff.
That's right.
And remember too that, just like in the old days, we had to learn that polling host is much slower than event-driven, convergence. It's the same thing in the network, right? The routing protocol is still going to have to be down there somewhere, not just because we're going to have to get all these SDN pieces together, but because somewhere that control plane has to know that, that link just failed, and there's a control over that. There's got to be, but there's got to be something in the middle that makes things happen while those things happen.
So that brings up a very good point. We talked a little about SDN standards. So today, OpenFlow is run by the Open Networking Foundation. And the Open Networking Foundation now has 2 protocols, OpenFlow and NetConf, which is using for the configuration for that which is not NetFlow. So just because a switch has NetFlow entries in it, it still needs to have IP addresses and speeds and feeds, and that's not part of the NetFlow standard. So NetConf takes care of that. But there's still a whole range of other standards that need to be developed. So controller-to-controller APIs. What about application-to-controller interfaces? Should we be having standardized application controller? So while we might have defined the controller to the switch, and the simplest, the lowest common denominator, which is OpenFlow, there's a whole range of other standards, and we still don't know which of the certification bodies that we have today, IEEE, IETF, MEF, any of the other many standards bodies may yet choose to chime in and try and engage in the SDN to set up those types of standards.
They're all getting their toes in the water. And we kind of talked about this in the pre-brief to this, right? There's a couple of different philosophical approaches. I think from our perspective, we expect to be a marketplace or an ecosystem, an SDN ecosystem of diversity, where you'll have purposeful protocols, things that are tuned for a particular use case. QoS management, video management, those kinds of things. I think there are other folks that like to see the Uber, trying to see the Uber controller, the Uber protocol. Having built a few of those ourselves, we find not necessarily the best thing sometimes. It's cumbersome to get out the door, and there's, geometric or exponential complexity in trying to do some of these things. But I think at the end of the day, you see the market fast forward 5 or 6 years. I think you'll see that diversity for the market, which I think is good. I think there'll be OpenFlow. I think there'll be other things. There'll be different controllers. I mean, a lot of the northbound interface out of the controller is still wide open territory. There are very few folks that are having that conversation or even exploring how to do that. A lot of the conversation is southbound between controller and data plane.
That's right. And that comes back to what Derick was saying, is today all controllers are islands.
Yep.
But are you really going to buy a controller in your network that doesn't interoperate with another one? So maybe you have a controller that's focusing on switching through your network, and we might see controllers in the future that specialize on routing in the WAN edge. But those two will need to interoperate. And we haven't had those discussions.
And hopefully the standards organizations that are out there will sort themselves out based on what needs to be standardized and what they specialize in. And hopefully the ITF focuses on Layer 3 control plane standards in relationship to OpenFlow.
That gets hard. That's going to get...
Yes, I understand
because there's so many functions out there that an individual device can do. And we're talking different classes of devices that can fit into this scheme. A router does something different than a switch, which does something different than a firewall, all of which could be compartmentalized into an SDN scheme like that. So how do you build a standard group of APIs, if you will, that are going to call on some standards? And it's the lowest common denominator.
But look at the case of Trill and the 802 work, right? And that the way the IEEE and the ITF have actually sorted out their arguments, and MPLS is the same way, MPLS TE, ITU, and ITF. There are liaisons here, and again, maybe I'm appealing to my better nature as a, former member of the IESG and all this other stuff, working in the ITF all the time, that that people will be reasonable and figure out where they have the expertise and where their organization works best and where they're, because the ITF and the IEEE aren't just different because they do different things. They're different structurally in the way that they create standards. And so the IEEE produces certain standards better than the IETF does because they are a one company, one vote organization, whereas the IETF is much more running code and rough consensus.
I agree with that. I think that'll happen. I'm not going to be the optimist. I think the problem is this: I think you're trying to build a bridge, and you have folks on one side, and you have folks on the other side. Yeah. They're starting, in their areas of expertise.
Everybody thinks that they can get to the middle of the bridge first, and they own most of the pie.
Or even when they bring together, there's no guarantee the two ends will line up because they started where they understood, like you said. But it's where they start to touch. It gets interesting because they didn't necessarily plan on that piece.
Sure.
And even when you have a standard, I mean, remember the old days of Ethernet with, DICs and Type 2 and those kinds of, you can have a standard, and the standard still won't interoperate. You still have to sit there and look at packet header, okay, is that a length field or is that a type field? You still have to go through that weird.
Well, we have a lot of that still in SNMP, going back to the SNMP.
Yeah, and honestly, I think one of the things that I've learned about a lot of the standardization, like when we were going through the cloud storage stuff a few years ago, there was this whole idea of, do you want a prescriptive developed in advance standard that boils the ocean, or do you want to let 1,000 flowers bloom and see which one is the most vigorous? Yep. And personally, I would much rather watch and wait and see what happens than have somebody create another Bluetooth with specifications for every little stupid application that nobody's going to ever use. Basically, you look at the standards that have failed to really take over the world, and you've got things like Bluetooth and Fiber Channel and FireWire and things like that where they tried to boil everything into it. And which one succeeded? Ethernet, IP, where they basically put together a couple of small things and step back and let's see what's going to happen here.
And maybe that's a good thing about the 6,000 RFCs that everybody whines about. It's
Absolutely.
Probably only about 1,000 of them or 900 of them are actually used today, and that's a good thing. That's not a bad thing.
And people are coming up with ideas.
At least we've got standards.
And at least we've got standards.
You look at
well, I don't know about you, Greg.
Well, to be fair, right? So your Microsoft Windows Server 2008, how many standards are in there? Have they got 6,000 RFCs that are open for everybody to write to, or are they all closed? So most of the IPOs on Microsoft.
That's a whole other podcast about
standards. Anybody who wants to say to me there's 6,000 RFCs, that's just too many standards. I want to say, well, actually, I'd rather have some standards than none. So VMware has none. They don't share their data with anybody. They don't make their system open to anybody.
Well, they do when they want somebody to implement it.
Well,
and then they say that you're going to do that.
Yeah, it's the standard that you can have. You can choose this one.
Welcome to vShield.
Yeah, that's right. So, so speaking of vShield, that's a great way to transition into the third part of today's announcement around the SDN strategy, is that the Nexus 1000V is now being extended to deliver VXLAN. Mm-hmm. So in the past, those of you who've listened to the Packet Pushers podcast will know that we've extensively bashed up VXLAN for being a dumb idea, right? However,
like so many dumb ideas.
It's a dumb idea with traction.
Yeah, the magic flute doesn't seem to have stopped playing. So as VXLAN continues to get blown into on the Magic Flute, now that the Nexus 1000V, to summarise that, we're seeing the Nexus 1000V will now participate in creating and terminating VXLAN tunnels.
And it has the new thing is it now gives you a way to bridge your existing VLANs with your VXLANs, which is what's new with the announcement. So whether you like it or not, it's the standard. And you got enough big dogs that are pushing VXLAN. It's going to be the way to do things.
VXLAN is a terrible idea, except for all the other solutions to that problem,
which
are even worse.
It's the best of a bunch of bad ideas.
Yeah, and being able to bridge VXLAN to VLAN, good idea. Just plain good idea.
That's a lot of what we hang our hats on is trying to get consistency between physical and virtual, right? We do that with services, we do that with networking, we do that with virtual LANs of whatever flavor now. Still at the end of the day, you should not care whether something's running on physical or virtual. It should behave the same. So that's part of the progression for us. Is you've got VLANs, you have them, you love them. We've got VXLANs, which you have, whether you like them or not. At some point, you just need to have them. Need some transparency with them. for traffic and those kinds of things. I think the other piece that's interesting for us is we really started to open up northbound interfaces. There was an interesting Twitter conversation like a week or so about whether 1000V is SDN. I actually argue at this point it isn't. I mean, it's got a client, it's got a control agent architecture, which is kind of cool, and it's proven it's scalable. But until we did the quantum API and the RESTful API, I'd say it's not, because there's no northbound programmability to it, except through the XML piece. But I mean, this is more traditional API type access. So, I think that's really the third piece in terms of starting to open up some of these capabilities. And again, it's an SDN solution. It looks nothing like controllers and agents. It looks nothing like APIs. And that's why you see it kind of, we had some conversation about whether we're setting direction or whether we're copying out with this approach.
Well, you can look at it both ways.
Yeah.
In a sense, Cisco's not staking out a space and leading here, because there's no space. Well, you could take the view that there's no space to lead into because we can't understand the problem.
Yeah, I mean, the customers, literally, our customers are not, there's no correlation, right? Other than we like the concept and there's an immense amount of potential coolness. The how we get there is still up in the air. And I think that, the other piece of that, especially on the enterprise side, most enterprise customers, if you're a network engineer and you're working for enterprise, odds are, if you're still employed, your network's up and it's running and happy. If you're going to disrupt that, you need to be able to tangibly do something better, cheaper, faster, different. And I think that's a hard case to make right now.
So VXLAN does just to recap, so VXLAN does a few things for us. It allows us to decouple the edge from the core. So once a packet is encapsulated in the VXLAN frame, it then routes over the core in an IP. It gives us 16 million VLANs, because effectively each VLAN can then have 4,000 VLAN tags inside of each one, and so you get your 16. That's very important for the cloudies, the public clouds, who have very large numbers of machines and whatever. It also allows you to do layer 2 over layer 3, which is a safe way of, if you're going to do virtual machine migration, then the ARP and the IP to a MAC address mapping can move between them. And that can all happen outside of your physical network to some extent. The challenge behind that, of course, is that the networking team loses control of visibility into it to some extent. And so the fact that the Nexus 1000V gets into the fast path of the VMware stack, of course, means it actually gets new paths. It's into the VM Direct Path 2.0 standard or something. Yeah. So that means it actually now gets into an even faster performance where it's in kernel mode of the VMware ESX. So it runs like the clappers, basically. It's not slow. It's as fast as it can be.
Or we can bypass it altogether.
Yeah.
Yep.
But the Nexus 1000V is exposing these northbound things so that we can actually Cisco can start to roll out applications which show you the VXLAN mapping over the top. Now, the other side of the SDN announcement, and this is something I wanted to come back to, was that Cisco already has an extensive suite of XML APIs. So, for example, in the ACE, that's been there for 6 years. They've been exposing XML APIs there. But as you said, we haven't taken advantage of them. And I think the great news about this OpenFlow announcement is it should sort of say to people, we need to be thinking about using software APIs. Maybe we need to go back and invent Perl again. Remember the old days we all used to sit around and write Perl scripts in SNMP to do things before we got network management platforms.
So we've had with all the NXOS platforms, right? They've had published XML schemas, and I'm sure tons of people take advantage of that. The one place on our portfolio they do is on the UCS side,
which is unfortunate.
Not the UCS thing.
Yeah.
But I think it's a spanning tree.
But I think it comes down to I'd love to hear the feedback. Do you feel that the investment is worthwhile to figure out how to do things through XML? Are you happy with whatever you're using right now, whether it's Cisco stuff or not Cisco stuff, is good enough? Because that's really what it comes down to, right? Is there enough of a delta to justify the investment?
There's an issue here where the people that are network engineers programming the network are very used to the CLI, and they're not going to necessarily, on an individual basis, look at an XML API and say, oh, I can use a script that does these calls, and it's just different. I don't know that it's necessarily better. But you take a third party who wants to write a fancy management application and then writes to those APIs. That could make sense for them there.
It could.
But isn't it unfortunate that we've gotten to the place in the world of networking where we think of networking as CLIs?
It is extremely unfortunate.
It is extremely unfortunate. But it also took many years for Windows like Microsoft developed PowerShell in 2007-ish time frame, and it's only sort of in the last 2 or 3 years we've seen Windows administrators become proficient at using PowerShell to automate tasks.
Well, it took until Server 2012 to get PowerShell sufficiently dispersed throughout Windows to have it be useful generally.
Yeah.
I mean, look at Exchange 2010. It is basically a GUI running on top of a whole bunch of PowerShell commands, and yet people still felt more comfortable using the GUI than they did the PowerShell commands until people dug into it and found out all the other things they could do when they didn't rely on the GUI to do it.
It's a trust issue. You get used to doing something a certain way. You know when you type this command into the CLI, the router, the switch, or whatever it is going to behave in way X. Now, if you abstract that and put some third-party tool on top of it that does an XML call to do the same thing, what if it doesn't work right? What if your trust level there goes down? So there needs to be a demonstration of the technology as trustworthy to accomplish the same thing. Now, one of the most telling things about that is if you see such a thing in action and you try it and you begin to develop the trust, then maybe you go in that direction. But most people are just like, I'm used to doing it my way, I'm not going to change.
Right, you need to wade in, right? You need to start with small pieces along the edges, just like with the PowerShell. You need to figure out the things you can do with it. Go try those things. If they work, then you productize them or you put them in production, and then you move into other areas. But I think that's the way it's got to be done. I mean, that's the way the trust issue works in the networking industry.
So I think maybe a couple of ways. So I think that the thing with GUIs though is it's like bowling when they put the little bumpers down on either side, right? At the end of the day, if you're in a GUI, it's probably not going to let you do stupid stuff.
Yes.
Right. With you're sitting there at a command line.
I don't know.
More so relative to just sitting there at a CLI prompt, where you can do all kinds of stupid stuff and not realize you've done stupid stuff. And that's the trade-off, right? I remember back to the Cisco Wellfleet days. Wellfleet had that god-awful GUI sitting on top of their god-awful SMB implementation. It looked pretty. I mean, it could let you do anything, but it was god-awful stuff. You're sitting there needing to
and you had to have
set up an interface. You can do it in 30 seconds here or 5 minutes.
But let's be honest, CLIs have their limits, and even GUIs have their limits in these environments. As things become more complex, I mean, look at QoS configuration 5 years ago, and look at QoS configuration today. There comes a point where it's easier to do things differently.
The difference might not be that as much as how dynamic the environments become.
Yes.
I think the thing is, if you have complex, I mean, how often do you really configure QoS, right? You'll do it once, and hopefully you won't touch it again for a long time.
Yeah, exactly. Exactly.
I mean, relatively, right?
No,
I think if you look at some of these things like cloud and some of the ways different networks are being used differently, it requires a much more, I hate to use agile because it's a marketing term, but there's a lot more consistent day-to-day churn in a network. And I think that's where things break down. I think that's where it starts to drive behavior. Like, I just don't have enough hours in the day to handle
BGP configurations, right? How many times do the Bogon routes change on a daily basis or a weekly basis or whatever it is? When you start getting into BGP security, what happens when all the filtering has to change every day or every 2 days? When all of a sudden you're out there configuring filters constantly, well, there's got to be a way to stop that nonsense. I've got to get that off my back so I can do it.
It's not just the configuration of one device that's been impacted by some event or some change.
It's all your edges.
It's all these different devices that
right,
you got to touch. So you want to implement a new policy, or to give an example, I wrote in a blog post, just to want to provision VLAN, I got to touch a whole bunch of different devices to make them go. There's a very wide impact to the network just because of the introduction.
And of course, you can do all that with a management workstation, right? The screen scrapes everything, but then the management station itself becomes the center of complexity in dealing with that management station. Whereas if you have an XML interface into all those devices, and you can actually write something that does what needs to be done on all of them, then it becomes a matter of coding it. And the coding paradigm is much more better understood.
That's right. And the code should be intelligent enough to say, actually, that's a bad idea.
Right.
And
then you can get into coding, good coding practices. I can actually check my code for validity. I can check my code for consistency. I can do all of the stuff that I normally do with coding projects. I mean, now I've transferred all those coding skills into the networking environment. And that's all a good thing for the most part.
And coding's come a long way.
But there's a long ramp up to that, right? I mean, there's going to be a lot of people looking at Stack Overflows at 2 o'clock in the morning when they start trying to code and stuff.
I mean, we just moved into utopia land in 5 minutes,
But I think that's the dynamic where there is no valid alternate way of doing it, which I think could drive that shift in thinking, right? It's when you get to the point where you just can't handle it anymore because, the volume of what's going on And you look at the difference with, moving a VM, right? Before in the old days, you have to you call security folks, call the network folks, call the storage folks. Say, okay, we need to move a VM now. Can we, it's at least 3-4 different trouble tickets.
Yep.
Look at that versus, the 1,000 V or whatever, where it just happens. It's a completely different operational experience. I think that's when you're operational in your application environment pushes into that. I think at that point it gets you to look at new behavior.
Well, the network can't be in the way of a business needing to make a change.
Yes, it can.
And it tends to be.
But when you talked about trust and you were saying is it a bad thing to have dependency? I think it is actually a bad thing. I'm working on a blog post about this. I think
it's right here.
Right now, literally.
He's reading his own blog post. It's cool.
Let's let the record show that he's not doing it.
I think something to say now.
Trust.
We've gotten away from actual systems engineering and network, and I think we need to go back to it. I was a programmer first, and when I was brought into networking, I was trained by an electrical engineer who he was brought up in an engineering environment, so his whole approach to networking was very engineering focused. And when I left that environment, I didn't see something like that again until I got to Verizon. And now where I'm at, I see it's on the opposite end of the spectrum. And I don't know what to call it. It's like ITism. Like they're IT heroes. What does the vendor say? Open a ticket. What are the specs in that box? Okay, buy it, throw it in.
Yep.
I mean, it's like
I actually think of it. I actually have this thing, but most people around the world know it as IKEA. You go to IKEA, you get a flat pack, you screw it together, and you've got yourself a chair. Woohoo! Right? The bits don't look like a chair, but if you screw them together, right, they do. You can actually get different bits from IKEA and actually turn them into something else. But a lot of modern IT is an IKEA flat pack. We just choose the right bits and then plug them together in a way.
And then the problem is we buy the flat pack for the table,
Yeah.
and then we buy the flat pack for 5 different kinds of chairs, and we put them all together, and we think we have a dining room set.
Yes. I mean, that comes back to the road question.
Yeah.
We've gone down this path in networking, and I think this is really what the source of frustration is where people think of the network as a collection of nodes that you log into, and that's about as much engineering and innovation that the enterprise level person can come up with, right?
Yeah.
Well, I put them together, the packets are passing. What do you want from me? Not my problem. And really, we're supposed to be delivering applications on the network.
Hmm.
And what I think what SDN represents is we went too far down this path of we started to lose our way. I think almost the CLI thing is a gleaming example of that. And now we're going to go back to what are we really wanting our network to do? And how can I make my network do that? And that's what SDN offers. That's what network programmability offers.
Well, we've moved out of the concept of theorizing the network as a system and made it into a bunch of little components we've stuffed together. And we need to move back to it really is a system, right?
It is.
It's not, you don't go out of the car dealership and say, I want that set of brakes and those spark plugs and that tire. You get out of the car dealership and say, I want a car. I want a car that solves these problems in my life. And today in the networking world, we're telling people, hey, there's that set of brakes and there's this, and you put it all together and put the jalopy, and it may end up a motorcycle with 15 different styles of sidecars on the side of it, But it's not a transportation system. That's where we are in networking.
So I think to extend that, I think there are 2 pieces to that, right? So first is, to your point, taking a systematic approach and building true systems out. But I think the second piece then is being able to turn them over and make them consumable and accessible to the true consumer of this, which is the developers, right? You don't need to be a mechanical engineer or an electrical engineer to drive a car. There's an interface to understand gas pedal, brake pedal, gear shift, radio.
We've abstracted the control system or the control plane to the point where anyone can do it.
Most developers are telling we haven't gotten there yet, but this is, I think, why they get excited.
Yeah.
They see the potential of being able to really use right to the network and say, I need a 10 gig link that's HD video capable, or I need a link that's secure that's with this type of encryption.
I'm a VMware server. Can I connect to VLAN 10?
Yeah.
And VMware server asks the network, can I have VLAN 10 on this interface?
Yeah.
On this trunk interface.
So I think that's the other side of this. When we talk a lot about the network side, which is cool, But I think ultimately it's really taking your analogies and extending them further out. So I think within the networking community, it's going back to taking a systematic approach. But then I think the other piece is then making it consumable and accessible to folks that wouldn't know a packet if it hit in the back of the head. And don't really, and frankly, don't care. And most developers don't care. No.
Well,
If
you're
it's
getting into
important,
one of my
keep shutting stuff down until it breaks, and I'm going to call and complain to the network down.
Yeah, you're getting into one of my
It's the
favourite.
calling and complaining part that they like the best.
You're getting into one of my favourite topics, which is networking people need to stop thinking of packets and thinking of flows. And flows are applications. But the problem is that for the last 20 years, we've just said everything's a packet because the value of TCP/IP has been the fact that it's a commoditized packet shipped across the network that's and are universally handled. But in reality, applications are flows, and that's where the OpenFlow proposal has been very successful, is it recognises the values of applications inherently, and then it exposes a control function which allows us to go forward. Now,
so I get this straight. So you're critical of these, quote, packet pushers who are...
Alright, you gotta change the blog.
Flow pushers.
Flow pushers.
Yeah, I think the Flow Pushers podcast sounds like a kind of a different topic.
Flow pumpers. Yes.
Yes.
I mean, it's symptomatic. That is a challenge. Most people, we educationally, historically, getting the packets to move from point A to point B was actually an enormous challenge. And in the last 3 or 4 years, we've actually gotten to the point where we can do it reliably, more or less, to the point where we're now actually asking it to, sort of style points. It's like skateboarding. When you first learn to skateboard, then all of a sudden you can start to do a flip, double flip and a 360. You can do it with style. It takes time to get to that level of confidence. The industry is particularly.
I'm thinking, what is a network engineer with style? I don't know. It's kind of like an oxymoron.
That'd be me. So, but the interesting. So, if people want to get involved, I guess one of the things we've extracted from this is that the programmability aspect is important. People should get out there and start to have a look at that. And Cisco, as part of their 1PK announcement, is that they've got to develop a portal coming up. People can go there and have a look. There'll be some stuff in the announcements about that, where people can start to have a look. Are we going to see some sort of initiatives around that to get people involved with doing more of that doing code, cutting projects and stuff like that?
Yeah, I mean, I think part of it is to really get the developer community fired up. That's the reason to do this. If you look at the Apple model, right, since they have their developer conference taking up, part of it's having really cool hardware and software. But then, the admin really took off when they exposed the developer kit and really let other people run wild and start taking the platform and adapting it.
Well, this is Apple. They don't let people run wild. when they let other people run in this carefully controlled path.
Enough to make talking about the bumpers of a GUI.
The bumpers of the bowling alley. You can run down that.
But there is another lesson from the Apple experience, and that's that you can give people tools and you can give people APIs, and they may not use it. iCloud so far has been almost useless. And the reason is people just didn't want to do it. So then you learn, you adapt, and you announce something new. And again, I think that that's much better than if you had just come out with, boom, this is what it is, use it.
Yeah, I mean, that's when we actually use the phone analogy, right? We look at the iPhone versus the Android model versus the Skype model. So the iPhone model very tightly, vertically integrated, right? We've got very tightly bound hardware and software with the developer API on top of that to make that all more accessible. So it makes sense if you got a rich set of collection. You got a mature platform, you got a mature operating system, a lot of feature richness, and what you're trying to do is open it up for other people to be able to play with. You got the Android model, which is much more decoupled, right? You got hardware from one location, software from another, so you have a lot more choice and flexibility. Maybe a little less control on user experience. It's a little squishier. Then you have the Skype model where you just have ubiquitous access, completely decoupled from the underlying hardware. So you got this, you get a ubiquitous set of capabilities, but maybe they don't take as much advantage. It's almost a lowest common denominator experience. Don't take advantage of any of the intelligence or anything else. There's no wrong answer in all that. It's just what depends what you're looking for. you pick what goes with you, and sometimes it's for technology reasons. Sometimes the Apple way may irk you, and you want the openness of Android, and that's why you make a decision. Sometimes it's a functional perspective.
So, and just one final topic then. So the Nexus 1000V, which is the third leg of the announcement, we talked a little bit about that. VXLAN is the overlay network virtualization piece. So part of what we're seeing in the OpenFlow deployment models that's coming out today is, other companies have developed this tunneling with overlays, and VXLAN is part of that. So Cisco is really actually announcing a whole range of options there. We support the overlay network virtualization capability via VXLAN and Nexus 1000V, which pits you against some other companies that have been successful there, or put you in the competitive space with that, which is fine. I mean, it's what you'd expect. But you're also saying, here's the OpenFlow APIs. We're going to drop that into all of the platforms that you expect. And if people run with it as we expect they will, so we expect they will, then we'll start that. We're in that place in that market with the 1PK initiative.
Well, so a couple of things. I mean, the tunneling piece is interesting, right? Because actually, I'm working on a blog post on whether tunneling is legitimate engineering or whether it's the duct tape of networking. And I think there's no right answer. But I think it's kind of understanding. Do you want to do? Do you just throw up tunnels because you don't want to engineer your network?
So duct tape isn't legitimate.
It all depends on what you're talking about. If you're fixing a Boeing that I'm flying on, no. I'd rather have the duct tape free. So I think we'll be I think we'll be somewhat agnostic to what tunneling protocols we look at going forward. Certainly, VXLAN is where our partners are. We have the announcement with Hyper-V support coming down the pipe. So they have a different take on the world. So we kind of stay open to all these kinds of things. Still trying to be somewhat agnostic and kind of see where customers take us. But I think the other piece, I've had customers come to me and say, I don't need VXLAN. I'm going to do all this stuff with OpenFlow. Just give me OpenFlow enabled hypervisors. I'll build my own tunnels. And I think it comes down to, could you do that? Yes. Is it a good idea? I don't know. Maybe not. I mean, how much reinventing of the wheel do you want to do?
There's features in VXLAN that you don't get with other tunnels. So VXLAN rewrites the header so it load balances across either channels, right? And that's not something that you can do with GRE tunnels, for example, because the header doesn't change. Therefore, you're going to be locked in, so you're not going to get the packet or the flow balancing over an ether channel.
If you're poking at NVGRE, they have their way around that. But,
yes.
But yeah.
Well, I mean, I'm saying, for example, the latest OpenFlow 1.3 standard talks about a tunnel interface, and you could pop packets into a tunnel using OpenFlow, and then that's an edge, and that was an announcement from somebody recently. It's not supported in hardware yet, but maybe over time it would be. But you can't load balance GRE tunnels. That's the value of VXLAN and NVGRE, is that they can load balance across ether channels.
But I think that the SDN conversation should always be contextualized in terms of what's available. Right? I mean, I always love Ivan's analogy of you proudly take the wheels off a car and put some slightly less round wheels back on it and say, voila. And I think for folks that are actually running networks, that's a lot of what it is. It's not, okay, is it cool? Yeah, is it cool? Is it help me do anything better than my network that's up and running and doing what it's supposed to? That's really, I think that's the hard question. And I don't think, I think for folks that are trying to drive traction, that's what they need to be able to answer. Some places yes, some places we'll see.
So that's it for this virtual symposium. Thanks very much to Omar, Sultan, and Cisco to come on and share some thoughts about the SDN, and thanks to all the people around the table who participated. There's so many of us and so many fantastic names that it's really hard to sort of let's skip that part today. We will have more information about the announcements. We'll be able to see show links about and related announcements from Cisco on this. And we have a couple more shows coming after this to dive into more about this area of the technology. So stay tuned for part 2 of this, which will be coming out in a few more weeks' time. Thanks for tuning in. See you later.